video is the part 2 of how prepared are you. And in this test, the question 1 says factorize completely 2x squared plus 5x minus 3. The question 2 says express 0.2727 repeating as a fraction. Question 3 says a solid cube of side 6 centimeters is melted and recast into sphere of radius 1 centimeter. Find I, volume of the cube, II, volume of one sphere, and the number of spheres formed. Right, so let us do a solution downwards. So the first question, let's look at it. Factorize completely 2x squared plus 5x minus 3. Okay, solution. Okay, so 2x squared plus 5x minus 3. Right, so this is a quadratic expression, and to factorize it we have to try to, and currently the quadratic expression is having 3 terms, right? So to factorize it, we have to try to express it in terms of 4. Okay, so to write this one in 4 terms, the general rule, which is s squared minus a plus b x plus ab is what we are going to imitate. But from this general rule, it says that some two numbers, when you add them, you're going to get a coefficient of x. So let's say the two numbers a and b, when you add them, you're going to get a coefficient of x in your quadratic expression, and then when you multiply them, you're going to get a constant, right? That is what this general expression says. But according to the general expression, the coefficient of x squared is what? 1. But the coefficient of x squared in our question is 2. So you have to try to express it in that format. That is, how do we let the coefficient of 2x squared plus 5x minus 3 becomes 1? So this could be possible by dividing each of the terms by the coefficient of x squared. So the coefficient is 2, we divide here by 2, divide here by 2, and we divide this place 2 by 2. But when doing that, this term, the first term, is going to have x squared plus 5 all over 2x, then minus 3 all over 2. Okay, now the next thing that we're going to do is we now look for the two values that when we add, you're going to get 5 over 2, and then when we multiply, you're going to get minus 3 over 2. So these two figures, we can test for them using a lot of numbers. Okay, but my first test, I am going to test with 3 and minus 1 on 2. Okay, so choosing these two numbers, let's see if it is going to work. If I multiply 3 and then minus 1 on 2, I am supposed to get the constant, which is minus 3 on 2. So let us see if it is possible. 3 times minus 1 on 2. So 3 times minus 1 is minus 3, then on 2. So I'm getting a constant, right? Okay. Now let us also see if we're going to get the coefficient of x, which is 5.2. And from the general rule, x squared, the general expression, x squared minus a plus b, x plus ab, we're going to add the 3 and the minus 1 and 2 to get the coefficient of x. So in doing so, we have 3 plus minus 1 on 2, and basically this is going to give us 3 plus 1 sorry, it's not 3 plus again, plus and minus, which one is going to dominate? Plus minus, we're going to have minus 1 on 2. This will be equal to the LCM of 3 minus 1 and 2. The 3 is over 1, so the LCM of 1 and 2 is what? 2. Then the 1 will go into 2. How many times 2? 2 times 3 is going to give us 6. And 2 going to 2, 1. Then 2 times 2 going to 2, 1. And then the 1 times the 1 is going to give us 1. So 6 minus 1 is 5. All on 2. Right, good. Then we had a coefficient of x 5.2 as well. So upon obtaining that, then what we want to do next is that we since when we add the 3 and the minus 1 on 2, we're going to get 5 on 2 as the coefficient of x. Then in place of the 5.2, we are going to write, we have 5 plus 5 all in 2x, then minus 3 on 2, right? So in place of this 5.2, we're going to have x squared minus 1 on 2x plus 3x minus 3 on 2. Actually, when I simplify minus 1 on 2x plus 3x, I'm going to get 5 over 2x. So I have not really changed anything. But now, how many terms do we have? We have 4 terms, right? Okay. So having 4 terms, we're going to consider 2 terms at a time in a factorization. But I am having denominators. I do not really want to have the expression in terms of fractions. So what do I do to eliminate these fractions in order to make the work very easier? The LCM of these denominators is what? 2, right? So I'm going to multiply 2 through each of the terms again, the 4 terms, right? So which is 2x squared, and then minus, so when I multiply 2 by this, 2 times 1 on 2x, okay, you let me write it, 1 on 2x, then times 2 plus 2 times 3x, then 3x, let me write it 3x, then minus 3 all in 2 by 2. We're going to have 2x, then minus these 2 will go into 2, 1, so it's going to be 11 minus x, and then 2 by 3 is going to give us 6x, and then 2 going to 2, 1, and then we're going to have 3 times 1 is what? 3. So this is the new form that we're going to have, right? and from this we have 4 terms, and considering the first 2 terms, I can factorize x out because there is x in both terms. So when x is factorized out, the first term we're going to be left with 2x, then the next time we're going to have minus 1, then the last 2 terms 6x minus 3, what is common in them? I can factorize 3 out, and when 3 is factorized out, what can I multiply by 3 to get 6x? That is 2x. What can I multiply by 3 to get minus 3, which is minus 1? Okay, now at this point, we in the bracket, we have 2x and then minus 1, 2x minus 1. We're going to write one of them, 2x minus 1, and then the coefficient of the brackets, x plus 3, we're going to write that one too in another bracket. And simply, this is the factorized form of 2x squared plus 5x minus 3. Okay, yeah. Now let us look at the next question. The next question says that we should express 0.2727 repeating as a fraction. Okay, so what we just solved, that was question number 1. So now what we're going to solve is question number 2. Question number 2. Okay, so 2. So according to the question, let us let x be equal to 0.2727 repeating. Okay, and if we look at it, the repeating digits is what? 27. Okay, and since the repeating digits is 27, which is repeating, how many digits are there? 2, right? So we're going to get 27. What can we do to get 27 out of the x? If I multiply the x, the 0.27 by 100, that is where I'm going to get 27, isn't it? So because of that, 100 by x, when you multiply 100 by the x, you're going to get 27.2727 repeating. Okay, you see, when you multiply this one by x, you're going to get that. Or if you cannot really see what I'm talking about, 0.2727 times 100. Yeah, so you're going to move the decimal point backwards how many times? 2. Okay, so that will be 27.27. But the 27 is repeating. You don't really know where it is going to stop, so you can repeat it. 27, 27. That is why I'm having these 3 dots, right? Okay, now let's subtract the x from 100x. So when we do that, we're going to have the 100x is 27, right? 27.2727 repeating. Okay, then minus the x, which is 0.2727 repeating. Now 100 minus x, 100x minus x is going to give us 99x. Okay, and the 27.2727 minus 0.2727 is going to give us 27. You see, we have 27.2727 repeating, right? And then the 0.2727. So when we do the subtraction, the whole of after the decimal point, all this is going to give us 0000, right? And then 27 minus 0 is going to give us 27, so it's going to be 27.000. That is why we have 27 here. But we're looking for the value of x, so we're going to divide both sides by the coefficient of x. Okay, we have 27 all on 99. Okay, so at this point 99, we're going to 99 1, so 1 times x is what? X. Then we're going to have 27 all on 99. But then we can simplify that. 9 will go into 27 how many times? Okay, now you let us use 3 first. 3 will go into 27 how many times? 9, right? 9. And then 9 will go into 99 how many times? 33. Again, 3 can go into 9 how many times? 3. And it will go into 33 how many times? 11. Okay, or simply at this point, 9 can go into 27 3 times, and you can go into 99 11 times. Okay, so therefore 0.2727 repeating as a fraction is 3/11. Okay, so we're done with the question number 2. Let's go to question number 3. Question number 3. So what does the question number 3 says? Question number 3 says that a solid cube of size 6 centimeters 6 centimeters is melted and recast into sphere of radius 1 centimeter. Find the volume of the cube, the volume of one sphere, and the number of spheres formed. Okay, right. So what can we say about a cube? A cube has 6 sides. Oh, sorry, a cube has 6 faces, right? 6 faces, and all the sides of the cube are equal. The volume of a cube, the formula for the volume of cube is L cube. Okay, L cube, and we were given that a side of the cube is 6 centimeters. That is going to be 6 centimeters cube, right? Cube. So 6 centimeters cube, we're going to multiply. It means that we should multiply 6 by itself 3 times. Okay, then the cube is gonna be affecting the centimeters. 6 by 6 gives us 36 times 6 centimeters cube. Okay, and 36 by 6 again gives 36, so we write 6 and 6 by 3 gives us 18. 18 plus the 3 is going to give us 21. So 21 centimeters cube. Okay, so the volume of our cube is 216 centimeters cube. So that is 3I. Okay, and the 3I says that we should find the volume of a sphere, and you know the question says that the radius of the sphere is what? 1 centimeter, and the volume of sphere is given us 4/3 pi r cube. This implies that we're going to have 4/3 pi, but the r according to the question, is what? 1. R is equal to 1 centimeters cube. So in place of r, we're going to have 1 cube, right? This is actually going to be 4/3 pi. Okay, but what is pi? Pi is known to be 22/7. Okay, pi is equal to 22/7. So we can do substitution for pi. 4/3 times 22/7. This is going to give us approximately 4.19 centimeters cube. Okay, so the volume of one sphere is going to give us 4.19 centimeters cube. So if a sphere has a volume of 4.19 centimeters cube, and then the total volume of the cube which was formed is found to be 216 centimeters cube, and you want the total number of spheres that could be formed, then all what we got to do is to divide the total volume of the cube by a single volume of the sphere. So in finding the number of spheres, we're going to have 216 centimeters cube all divided by 4.19 centimeters cube, and in doing the operation, this is going to give us approximately 51.5 centimeters cube. Right, 51, sorry, no cube, because here the unit centimeters cube is going to cancel out, so just going to have 51.5. okay, and we are asking of the number, so it is going to be a constant, no unit is attached to it. So therefore the number of complete spheres is 51. 51.5. The 0.5 is a half, and we're looking for complete spheres, and we can get 51 complete spheres, right? If you find this video interesting, subscribe to the channel for more of such. See you when I see you.